All right, so we're skipping 7.2 today and going straight to 7.3, the tangent ratio. So I need you to learn this, learn it well. SOHCAHTOA. It is the number one thing in trigonometry. We're going to be learning the trigonomic ratios, tangent, sine, and cosine. And this saying SOHCAHTOA, which I'll explain in a minute, is the number one thing to get stuck in your head. I just called my dad. He's 66. I said, okay, I'm doing trigonometry. He said, SOHCAHTOA. Like, you got to remember that. You'll remember how to do the angles for the next 50 years. All right, so we are looking at our scientific calculator. So you need to pull out your calculator, whatever you're using, and make sure that it is scientific. These are the buttons that we are using. Today we're talking about tan. Tomorrow we're going to be talking about sine and cosine. So every calculator has them in a different spot. You'll notice there's a second function button on all calculators. So if you click the second function button and then hit any one of those buttons, you're getting this one on top. And if you can read that, we have a tan button, and then we've got what looks like tan -1, and that's inverse tan. So we got to make sure you've got those on your calculator. In this one, it's these three buttons, and all of them have the second function button where you can see the negative or inverse tan, inverse sine, inverse cos. Those two functions are opposite. Same as multiplying and dividing are opposite, adding and subtracting are opposite. We've talked a lot about the fact that square roots and squares are opposite. Tan and inverse tan, sine and inverse sine, cos and inverse cos are all opposite functions. So you can go in, they're like going in the opposite directions, or going back again. I guess you could think of them as going back again. So make sure your calculator has these things. Ensure that if you're finding you're getting the wrong answers, check to make sure that your calculator is set to degrees. Some of them are set to radians, and then that's a completely different. When we're talking about a circle, we're talking about 360 degrees or 90 degrees if we're talking about a right angle, that sort of thing. There's another system for calculating circles called radians, and we're not using those right now. So make sure that you are in degrees, or you're going to get different answers. So parts of a triangle. So we're using these functions, or in this chapter 7, we are only going to be talking about right angles. So this is only about right angle triangles. And now we are going to be finding information about the different parts of the triangle using tan, sine, or tangent, sine, and cosine, which in short form is tan, sine, and cos. So these three things are our trigonomic ratios. So we are going to be looking at how do we find different angles. So we're looking at how to find the angles. So if we know that we've got a right angle, we can name the other two angles, and we often use Greek symbols as angles. So we need to get used to that. This guy, which you're going to see in your book all the time, is theta. This guy is also, a common one, and that's phi. And you also see fishy guy, alpha. alpha, and sometimes you see beta, which it just looks like a B, but usually kind of an elongated music notey type beta. So those are the common names. Sometimes we just use X and Y and things like that, but we mostly use Greek letters when we're talking about angles. So I'm going to call up here theta, and I'm going to call down here alpha. So parts of a triangle. If it's a right angle, this is always the right angle. So we know that. I'm pretty sure we start learning that pretty young. You should also know that this guy is the hypotenuse. I don't expect you to remember how to spell it, but you should know that is the hypotenuse. I gotta look it up. So we've got two other sides of this triangle. So they switch back and forth depending on which angle you're talking about. So whereas the hypotenuse stays the same no matter what's going on, it is always the one opposite the right angle. It's always the longest side, the slopey side, the one opposite the right angle. So we should know this word. But now the other two are called opposite and adjacent. And so right now I'm just going to talk about theta. And if theta is there, then the opposite one, surprise, surprise, is the one opposite across from the angle that we're talking about. So that is the opposite of theta. Adjacent means beside. So the closest to. So I would say that CIA is adjacent to Jordan's Village. We're right beside each other. So this one is adjacent to theta. So now if we're talking about angle alpha, those two switch. So now this line, so we're talking about the lines all the way. So that's the hypotenuse, the length. So the length of the lines. So this length of this line is adjacent to alpha. And then this line over here is opposite of alpha. So we've got three lines, and those three lines are the lengths of those lines are important in what we're going to end up doing. And so opposite and adjacent switch places for the one that's across from it versus the one that's right beside it. One that's across is opposite, one right beside is adjacent. So now, stop and think if you can figure out what SOHCAHTOA might mean. So what SOHCAHTOA is the three ways of figuring out those angles. So when we use tangent, or let's start with, so we're talking about tangent today, but in order to teach SOHCAHTOA, I'll start with sine. So sine of an angle, so sine theta, equals opposite over hypotenuse. So really we should write it SOHCAHTOA, like that. So as you can probably figure out by now, that cosine equals adjacent over hypotenuse. And our one for today, tan theta equals opposite over adjacent. So that is SOHCAHTOA. Learn that. This is just a quick preview of where we're going. Today we're just going to be focusing on tan, and our next lesson is sine and cosine. So right now we're just looking at tan. So tan of an angle equals the opposite over the adjacent. Attached to this lesson, I've got another music video that can get stuck in your head so that you remember SOHCAHTOA, and it also explains a little bit of what it means too. But we're going to skip it in this lesson. Nope, that's not what I'm doing, dude. There we go. All right, straight into example 1. Find the tangent ratio from the given side. So find tan theta for each triangle, express as a fraction and as a decimal, correct to 4 decimal places. So we want to find tan theta of this angle. So this is theta in that corner. So we just need to know SOHCAHTOA. So our T is opposite over adjacent. So our opposite over adjacent. So tan theta equals, what is opposite to it? First figure out which is the hypotenuse, always the one as far away from the right angle as possible, always the one that is the biggest. It's always the biggest number. So if we're looking at theta, our opposite is the 5, it's the one farthest away. And our adjacent, our right beside, is 12. So as a fraction, we've got 5 over 12. As a decimal, so again, this is the absolute correct number. I am now going to write a dot over top or make squiggly lines because now we are rounding to 4 decimal places. So if you did 5 divided by 12, you're going to end up with 0.4167. And that's tan theta. In future, we're going to figure out what the angle is based on this. But this question is just asking for tan theta. It's not asking for what theta is. So there's one more step. So this is correct based on what's being asked. But the next step would be to start with tan theta equals 5 over 12. And just like when we are doing anything else, we want to isolate theta if we're trying to find that angle. So we would move that to the other side and switch its sign, basically. What is the opposite of tan? Just like I showed you on with the little pictures. It is inverse tan of 5 over 12. So in your calculator, you would put in inverse tan 5 over 12, or sometimes you have to put bracket 5 over 12 and then second function tan. So this is about using your calculator. This next section is all about understanding how your calculator works. So if you don't like your calculator, it's time to look around the house, try and find another one, try and figure out how it works. And I don't have my calculator, so maybe I should sit with my calculator. So you would put that into your calculator and that would tell you what the angle is, what actual theta is. But we are not being asked to do that in this question so far. But for reference sake, all right, so here is the answer as given in the book. So again, they just want the simple answer. We're not actually trying to find the angle for this one. They just want to know what tan theta is. So again, find tan theta for all of these. Again, we've got a right angle. Opposite the right angle is the hypotenuse. Now we've got theta down in the corner here. So what is opposite theta? Directly across is opposite. Closest to it is adjacent. So we know we've got TOA. SOHCAHTOA, TOA, always go back to that. So tan theta equals opposite over adjacent. Tan theta equals 6.8 over 4.5. And if we were to put that into a calculator, it would be approximately 1.5111. Answer in the book, same as ours. And again, this is just continuing practice, finding tan theta. So these two are the same, oops, come on back. We've got the same triangle, but we've got the different angles. So now we want to find, in C, we want to find that angle. So we've got the same numbers. Come on, switch pages for me, buddy. Nope. So we've got the same triangle, but now we're going from a different angle. So now we've got our opposite is there and our adjacent is there. Oops, sorry, that's hypotenuse. Damn it. So we got to make sure we mark our hypotenuse first so that we never do that. And our adjacent is that one. So we end up 4.5 divided by 6.8. So we've switched them because we've switched which angle it's going to be. And this is approximately 0.6618. So that's all to those questions. So that's your number one in your textbook. Come on. Number two is just calculator work. So it's just figuring out how to use your calculator. So some calculators make you put in tan first, then brackets 25. Sometimes you're putting in just 25 and then hitting the tan button. It's just a matter of knowing your calculator. So the answers are, please pause this and practice this. A is 0.4663 and B is approximately 1.7321. So please pause, take out your calculator, make sure that you can get those answers. So there's some tips, they're also in your textbook. about how to do it. Sometimes you have to press in different orders in order to get what you're doing. So make sure you understand your calculator. But that's all you have to do. Put it in the calculator. Calculators have an inverse function. So we already talked about this, inverse function ratio. If you know your ratio is opposite over adjacent, you can find the angle whose tangent this ratio represents. So this is using our opposite button. So we want to be able to press second function and then that inverse button that we went through at the very beginning. So this one we're going all the way. Example 3. Fiona is building a skateboard ramp. She wants the ramp to be 1 meter high and a horizontal distance of 2 meters. So we got 1 meter high. That's not a very good representative of 1 meter and 2 meters. Closer. And then so we want to know (1 meter and 2 meters, we're obviously rise over run, 1 meter and 2 meters, and we've got a right angle there. At what acute angles should she cut her wood roundest to the nearest tenth? So what angle is that going to be? What angle is this going to be? We got 2 little angles in here. And we got to figure out what we need. So let's give them, this time in the text, let's do it the way the textbook does it. Give it A, B, C. So we're looking what angle A is. And we want to know what angle B are. So other ways to do this is we could put a little theta in there, put a little alpha in there, make them, give them names on the internal side. But this is another way to name angles. So I'm just showing multiple ways of doing it. So mathematically, let's start with angle A. We want to find the tan. We can use the tan because we know those two numbers. We can't use sine and cosine yet because we don't know what the hypotenuse is. We can use this to figure out what the hypotenuse is, but we don't know it right now. So that's why we're using tan, because we're given the opposite sides and the adjacent sides. So what are opposite and adjacent to A? So obviously, I'm using a highlighter. This is always the hypotenuse. That's why I did it in a different color. But line BC, when we're looking at angle A, is the opposite right now. And angle or length AC is now the adjacent. So if we're talking opposite over adjacent, which we always are with tan, then the tan of angle A is opposite to over adjacent 1. So we've got the tan of 2. So we want to find the tan of 2. So as I said, we're isolating the angle A using the inverse function of tan for 2. And you just have to figure out how to put that in your calculator. So you might have to press 2. So you might have to press 2 and then second function and then tan to get that inverse function to work. You might have to put in you might have to do second function first and then tan and then 2. You might have to put brackets in there. Again, learning how your calculator works. So take out your calculator, see if you can find this answer. Because the answer you will get on your calculator is 63.43494882. And so we're rounding that is approximately We're going to go to 2 decimal places on that one. It doesn't round to the nearest. It says round to the nearest degree, so where nearest degree, sorry, would be equals 63 degrees. So that angle at the top is 63 degrees. Now there's 2 ways to find angle B. Angle B we could do exactly the same as we just did. Let's switch colors. We could say that the tan of B equals opposite over adjacent, which is now 1 over 2, because now we're going from this direction. And so our opposite is now the 1, our adjacent is now the 2. B equals the inverse of tan of 1/2. B equals 27 point, or sorry, it would be 26, almost 27 degrees, I was rounding. 0.56, approximately that. And then we would round it to 27 because it did ask to be the nearest degree, even though we probably wouldn't be rounding it so much in real life. Or we can think of it in terms of the triangle to find B. So A, C, B. If we know that this is 90 degrees and we know that this is 63 degrees, or we're rounding it to 63 degrees, then we can use what we know about triangles and say B equals 180 degrees minus 90 minus 63, because we know that the angles of a triangle have to add up to 180. So if we subtract the other 2, we're going to get what's left over. Those are all degrees. Pause if you want to see their answer. Wait for me to be able to turn the page. So note that in method 1 is more accurate for the measurement of the angle, since you're given all the information. Because we rounded to 63 degrees, the first one was more accurate. But we know that now we are building the skateboard. We write a sentence because it's a word problem, that she is building, cutting her angles at 63 to 27 degrees. Come on. Example 4, find the side lengths using the tangent. So now we're given the angle. Oh, man, this thing is jumpy today. So now they're giving us the length of one side. They're giving us an angle, and we're trying to find x. So again, write out our formula to begin with. So what information do we have? We know this is the hypotenuse. We know this is the angle. So we know what theta is. It's 28 degrees. We don't know what the opposite is, because that's our x. But we do know what our adjacent is. So we fill in our information. So like we tackle any math problem. Write out your formula, fill in the information that you have, solve for what you don't have. So now we can put tan 28 into our calculator to figure out what that is. Or we can rearrange our formula first. So we want to isolate x, basically. So I'm going to move, again, all of these skills we talked about at the beginning of the year, they come in so much handy. We've got to figure out how to do that, how to move the 9.2 length. So because we're isolating x. So because we're dividing x by 9.2, we need to either times by 9.2 on both sides, or switch it to the other side, change the direction. So going from dividing to multiplying. 2 ways to think about it, but we both end up with 9.2 times tan 28 degrees. Now, again, tan 28 degrees just goes into the calculator. Figure out, do you have to press tan bracket 22.8 bracket, or do you have to put in bracket 28 bracket and then tan, or do you have to just put 28 in and then hit tan? All calculators are going to work differently. Once you have that, you multiply it by the 9.2, and you end up with x is approximately 4.891. So, and we're working in centimeters, so centimeters. The length of, so then we can write it out. The length of x is approximately 4.891 centimeters. Round to the nearest tenth. Ugh, come on. So jumpy today. So x is about 4.9 centimeters. So these are some of the ways that you might have to put it into your calculator. Example 5, solve a multi-step problem using the tangent ratio. A radio transmitter is to be supported by a guy wire as shown. So a guy wire is like the tent pegs on a string on a tent. It kind of holds it up. So it's bolted into the ground down here, and then it holds the thing up there. There'd probably be one on either side or all four sides, something to hold it up, but that's what a guy wire is. The wire is to form a 65-degree angle with the ground and reach 30 meters up the transmitter. The wire can be ordered in whole number lengths of meters. How much wire should be ordered? So, how much wire should be ordered? We are going to have to round up. We know that. At the end, we need to round up because it doesn't, if we're trying to make something and we order something slightly less, we are going to be short. So we have to know that's telling us we need to round up. So we want to know how long the guy wire is going to be. So here we're actually trying to find the hypotenuse. So we need to find, this is a multi-step problem. So we're going to figure out, we're going to use a couple different things on this one. First, we want to find, so next we're going to end, next class, we're going to learn sine and cosine. So you would actually use sine or cosine to figure out this problem, which is what's throwing me off. But we can use tangent and the Pythagorean theorem together. So if we're looking at this one, our opposite is there. Our hypotenuse is what we're trying to find in the end. And our adjacent, we also don't know. So if we found our adjacent, we could use the Pythagorean theorem to solve and find the guy wire length. So that's what we're being asked to do in this one. So if I just have my formula, tan of 65 equals 30 over, and I'm just going to leave it as A as adjacent. So we need to find our adjacent first. So we need to reorganize this formula. So we can't just move the 30 over because the 30 is on top. So we need to move two things to get this A to be isolated. So first we've got to get it out from underneath the 30. So it moves over the same way we did the other one, or we multiply both sides by A, however you want to think about it. We end up with A times tan 65 equals 30. Then we want to move the tan 65. So someone said in class, it's like cross multiplying. It is. You can move things around, same as it's almost like you're cross multiplying. So the tan goes underneath, the A comes above, and they get crisscrossed. So that's how we find our adjacent length. So we're looking at the length of this line. That's what's being represented here. So A equals 30 over 10. Actually, we're going to leave it like that. We're just going to leave it like that because we don't want to round at this point. So we're going to leave it just like that. Now we're going to use our Pythagorean theorem because we have, which is a squared plus b squared equals c squared, or let's call it h squared. You could also say opposite plus squared plus hypotenuse, or opposite squared plus adjacent squared equals hypotenuse squared. So the adjacent is 30 over tan 65 squared plus 30 squared equals mystery h squared. So if we did this very mathematically, so again, knowing how to use your calculator is number one. So I'm just looking out of the book and they're not doing it in very many steps. So I want to go 30 divided by bracket tan of 65 bracket to figure out what that number is. And then I want to square it. So I'm getting 13.989. And then I want to square this. And I'm getting approximately, so now we're talking approximate lengths. So h squared is approximately all of that plus 900. 30 squared is 900. And so then we would go h equals the square root, because we want to square both sides in order to get that, of 1095.7. And we'd end up with a length of 33.101. And we are looking at meters. So again, wires can be ordered in whole number lengths of meters. So we want to round up. Even though it's only a 0.1, we want to round up. So 33 meters can be too short. So .34 meters of guy wire. So that one actually is a silly question because we're going to show you in the next lesson how much easier it is to do with tangent, or with sine and cosine rather than, but we remember that we can always find a third length of a triangle by using the Pythagorean theorem. That's how they do it. So they left it all together in one bit before getting to the end. So that would be very complicated in order to put into your calculator. So I did it in a couple steps. Key concepts: the ratio of the opposite side to the adjacent side of an angle in a right triangle is called the tangent of the angle. So this is what we need to know. The ratio, the difference between the fraction of opposite divided by adjacent is the tan. And you can use a scientific or graphing calculator to express the tangent of an angle as a decimal. Find one or more of acute angles when both leg lengths are known in a right triangle. And you can also use your calculator to find a side length if one accurate angle and one leg of a right triangle are known. So basically what that says is, as long as I have two pieces of information out of those three, what the angle is, or what the opposite is, or what the adjacent is, as long as I have 2 out of 3 pieces of information, I can find the third piece of information. All right, these questions I want you to do as on one page or multiple pages, but do them separately and hand those in first as practice questions so that I can mark them and then continue on to the rest of the homework.